Welcome, friends. So, we have come here to discuss about the last topic of this course, Power System 1, that is sag and tension. We shall briefly discuss what is sag in the transmission line, what is the mathematical expression, or how or on which factor sag is dependent on, and thereafter we shall see some numerical problems. So let us proceed. Now, what is a sag? Let us say we have a conductor. Suppose this point P, let us say this point P and Q, these 2 points at the tip of the tower, from where this conductor POQ, from this conductor POQ is strung freely. POQ is the conductor is strung freely. That is very important. So now it is quite natural that when a conductor is strung freely from two towers, it will not make this shape. That means a straight line shape, but it will make a shape like this. This is the shape. This shape is looking like quite similar to inverted bow. It is looking like a shape of inverted bow. Okay, we call this shape as catenary shape. So now it is the line joining two tips of the conductor. So from this point and this lowest point. So let us say this point is X, and let us say this point is O. It means that this vertical distance is D. So the sag is nothing but D. So how it can be defined? It is shown in figure. The distance D is measured between the point of support. Point of support means Q or P, and the lowest point O of the conductor is called sag. So it is the maximum vertical distance from the point of support and the lowest point, that is XO. XO is the D. Now, intuitively we can understand, or we shall try to understand, few facts. Consider this diagram first. So this is two towers and one conductor is strung freely. Okay. Now, if you can understand, let us consider this second diagram. Okay. Now the span length. What is called span length? What is span length of the tower? Span length is the distance between two towers, two consecutive towers. Here it is L1. L1 is the span length. So span length of the tower is L1, and for the second diagram, span length of the tower is L2, where L2 is less than L1. Now, as L2 reduces, that means if the span length of the conductor or span length of the tower, if it reduces, that means if L1, or that means if L is the span length, if it reduces, then this sag goes high. That means I have mentioned here, it is written here, with the span length of the tower, sag is inversely related. What does it mean? Inversely related. Inversely related means if span length goes lower, then that sag will go high. Sag will be more. You see, in this diagram, sag is only this much, but in this diagram, if the span length reduces, sag is little bit larger. Okay. So span length with the relation of with the parameter of span length of the tower, sag is inversely related. So if the span length is reduced, sag will be increased. As a result, if sag will be reduced, then these 2 points, the tensile strength of these 2 points will be will be less. So that is why it is written the tension acting on the 2 points. This is point P and this is point Q. These two points will be directly related. That means span length reduces, then tension will be also reduces. This is the intuitively we can understand. If span length with respect to span length, sag is inversely related and tension is directly related. Now second one is length of the conductor. Second parameter could be length of the conductor. How the sag and tension is related with the length of the conductor. Same way we can understand. Let us consider these two diagrams. Let us consider this diagram, last one. Let us say black conductor. Let us say we have a black conductor. It is, let us say it is 100 meter long. And we have a blue conductor there. And let us say that is 110 meter long. So as the blue conductor, between point P and Q, blue conductor between point and Q is more. So if the conductor length is more, then their sag will be more. So that is why it is written with respect to length of the conductor. With respect to the length of the conductor, sag is directly related. And as the sag will be more, then tensile strength acting on these 2 points, P and Q, will be less. So that tension will be inversely related. So if the length of the conductor goes high, sag will be more, tensile strength will be less. That is why with respect to length of the conductor, we can say sag will be more. That is why it is written directly related, and tensile strength at these 2 points P and Q will be less. That is why we call it it is inversely related. Parameter is very important, weight of the conductor. Third parameter is weight of the conductor. Again, let us consider this diagram. Let us say for the black conductor, let us this ways, let us say roughly, let us say it is 1 kg. Okay, weight. However, for the blue conductor, let us say this weighs 1.5 kg. For just to understand, okay. So as the weight of the blue conductor is more, then naturally the sag will be more. That is why with respect to weight of the conductor, sag is directly related. So if the weight goes high, so sag will be more. And tension will be, as sag will be more, tension will be less. So intuitively we can say that sag D, it is actually dependent on 3 parameters. Sag, intuitively we can understand sag is dependent on 3 parameters. What? Number 1 parameter is weight of the conductor. So it should go directly proportional, intuitively. Okay. Second parameter is length or span length, rather. Span length and length basically the same thing, intuitively. So similarly, if span length goes high, sag will be more. Okay. So again, so we can understand if it is the direct relation. Now for all these three cases, we can see if sag is more, then tensile will be less. Sag is more, so sag and tension is inversely related. So sag is inversely proportional to tensile strength. So intuitively we can understand sag, that is D. Sag, that is D. What is D? This distance is D. Sag, that this distance is D. The sag is intuitively we can understand directly related or directly proportional to the weight of the conductor. Second parameter, it is directly proportional to the span length between two towers, and it is inversely proportional to the tensile strength acting on the tip of the tower. Okay, so these three we can verify later on by mathematical expression whether this relations will be valid or not. We can verify. Now some practical data is given here. Let us say we have a 132 kV transmission line. Now two parameters are extremely important. Let us say we have a tower, one tower and tower number 2. Okay, so what is the distance between these two towers, which is called span length? And what will be the minimum ground clearance we should keep? So if the conductor is taking a catenary like shape, so this should be the minimum ground clearance. Let us say this is L. So these two parameters are very important, span length and the ground clearance. So for 132 kV transmission line, the span length is kept around 350 to 360 meter, and minimum ground clearance it is 6.3 meter. Similarly, for a voltage level of 220 kV transmission line, span length is increased little bit, 360 to 380 meter, and minimum ground clearance also increases, it is 7 meter. Now we have 400 kV. If we have a 400 kV transmission line, you see span length increases even 400 meter, and the ground clearance is 8.8 meter. So as the voltage level of the transmission line increases, this span length and this minimum ground clearance increases. This is very important. As the voltage level of the transmission line increases, span length, that is L, increases, and the minimum ground clearance, that is we say L, that will also be increases. Now we shall shortly see on which parameter sag is dependent on. First, we have already mentioned weight of the conductor. Now when we mention weight of the conductor, it should be always written, or it should be always mentioned weight per unit length. So it's not kg, rather it should be kg per meter. Weight of the conductor should be represented as kg per meter. That means if it is a conductor length, then what will be the total length and what will be the total weight of the conductor? So it should be written as kg per meter. The second parameter is tensile strength of the conductor. That means how much tensile strength is acting on this point or any points along the length of the line. Okay, that is the second parameter. Third parameter mentioned already, span length of the tower, that is T, or that is that is called L. And fourth one must be some atmospheric conditions like temperature, wind flow, and ice formation. What is temperature? Why temperature is important? Because the resistance of any conducting material is related with RT is equal to R0 into 1 plus alpha T. What is them? It is RT is equal to resistance at T degree Celsius. Okay, resistance at T degree Celsius temperature. What is R0? It is resistance at 0 degree Celsius temperature. And then what is this alpha? Alpha is temperature coefficient of the resistance. Temperature coefficient of the resistance. So RT is equal to R0 1 plus alpha T, and T is the temperature change. So you know that if the temperature during summer, if temperature goes high, then resistance of the conducting material will be also high. So if the resistance goes high, then the length of the material will be also high. Okay, so you see, as the length of the conductor is dependent, directly influencing the sag, so temperature plays a very important role, right? Temperature plays a very important role. Now second will be wind formation. The effect of the wind formation will be discussed. And ice, of course, in winter countries like we have, let us say this is the conductor, and on the top of the conductor there should be a very thick coating of ice, like this. Okay, it is thick coating of ice like this. So this is the ice coating. So due to this ice coating, the conductor weight increases. So as this conductor weight plays an influential parameter in sag determination, then the ice formation even in our country, in Himalayas or in a mountain region, if ice formation is there, that plays a very important role. That will be influential parameter. So we need to consider the effect of ice coating on sag calculation in hilly region or in winter regions. So till now we have studied, or we have seen, what is sag. Why sag is formed? Because if the conductor is strung between the two loads, you can see this is the conductor, although it is not a straight. So if I fix in my two fingers, you see it is forming a bow. It is not straight. You see, if I am holding it rigidly, as I free my rigidness, it will take a catenary shape or inverted bow-like stroke. So this is why the sag is formed, and it is mainly influenced by three parameters. Number one, weight of the conductor. Number two, span length, and number three, the tensile strength at acting on any point along the length of the conductor. And we have also seen some atmospheric parameter, which is temperature, which is another one is wind flow and ice coating. So these all are making sag calculation important, and we shall see shortly one by one what are the effects. So till now we will end here the first phase of the sag tension lecture. Thank you.